So I think you guys understand the whole domain situation, right? You take the domain of each parent function and then you choose the most restrictive function. But sometimes the actual algebra stuff is a little much. So I just want to make sure that you guys are comfortable and you know when to stop, right? That's the biggest problem is we want to stop. Okay, so let me move. Well, no, we are going to keep going a little bit on this guy. Just kidding. Okay, so here's what we're going to do. Remember, we're going to take f of x, okay, and we're going to subtract g of x. Now, remember, when you subtract, you always want to put the function in the back in parentheses, right? Because you're going to have to distribute a negative. We're still going to have to distribute a negative here. But don't get confused about it being a fraction. You're just going to distribute the negative through the top. That's all that you're really going to do. So he's going to make you a minus x and a plus 2. That's all that's going to happen there. So you're still going to just have one denominator, just like we did when we were adding. And then you'll have 2x plus 3. That's the first numerator. And then you're going to have a minus x plus 2. Okay, so all I did was kind of combine everybody into the top. Is that okay? Okay, I just distributed the negative through the top of the second one, and then I put everybody on top together. All right, now we need to do a little combining. So 2x minus x is x. 3 plus 2 is 5. Okay, bless you. Okay. Oh. It's not horrible when you sneeze in your mask and it all just stays on your little face. I'm sorry. Okay. All right. So, okay. So, yes. So, does everybody see that we could actually do some things here? We could cancel some stuff because what do we have in the bottom? A difference of squares. Okay. So, I'm just going to stick well, I'll go down here. Okay. Oh, okay. So now we're starting to see some stuff here. Okay, so if we separate our difference of squares like this, right, and we have this in the top, then it becomes pretty obvious that we can reduce into this, and this is our final answer. Now, remember, you still have to worry about a domain. And so the deal was we keep that domain that we had originally come up with unless we need to add anything extra into it. That was kind of the deal. Well, what's the only thing now that really needs to be excluded? A 5, right? If we set x minus 5 equal to 0, positive 5 is really our only issue. Has positive 5 been excluded already? Yeah, but so has negative 5. It doesn't matter. That's still your domain. And here's why, okay? You cannot remove anything. Cannot remove from the domain. You can only put more restrictions in it. Okay, you can only put more restrictions in it. So I can't go up there and remove the negative 5 exclusion because I don't need it anymore. Because think of it this way. All right. The negative 5 was put in there to protect the parent functions, correct? The parent functions are the ones that made this baby function. So if you go in there and remove the negative 5, you have screwed up the parent function. You'll never get a baby function if you mess up the parent function. Does that make sense? You can't make it smaller. You can only make it bigger, right? You can only add things in to make it longer. I can't remove the negative 5. Does that kind of make sense a little bit? Otherwise, I haven't protected my parent functions, and then there's no way for them to get together to make the baby function. Okay? So kind of a weird situation, but you can't remove something that you no longer need. You can only put more stuff in it if something else were to happen. So that's one of the reasons I wanted to do this problem, just because, you know, that comes up in my math lab. Okay? Is everyone all right with that? All right. So as long as there's nothing new in here, I'm going to keep my domain. Okay. All right, let's move up here. I know I've run out of room. You might have run out of room too. I don't know how big you write, but okay. So now remember, we're going to multiply. Okay. Now we're going to multiply these guys. So I'm going to have f of x times g of x. Don't start freaking out on me. It's not really that bad. Okay, don't let your laziness show. I know that you probably think, oh my gosh, I have to put a parenthesis around this top and a parenthesis around this top and then FOIL them out. And then I have to do a parenthesis around here and a parenthesis around here and FOIL that out. And I'm going to be here forever and all I'm going to do is FOIL the rest of my life, right? Well, no. Just again, we want to make sure that you know what that looks like. That's what your numerator would look like. You can stop there. You don't have to FOIL it out. As long as you just put those functions in parentheses, my math lab will take it. Okay, and you can stop there. Now let's think about the bottom. Now we're going to multiply these two together. So instead of writing two of them side by side, we could just write that. You could write them both side by side, but this will be fine for the multiplication. You don't actually have to do all that work. Yeah, just stop. I mean, you certainly can do all the work, but my math lab will take that. So just,
We give you enough.
yeah, we give you enough stuff to do, right? Just take that. Oh. Okay, so what about domain wise? This is the same denominator we've had. So do we need to put anything else or change our domain? No, we're going to keep that domain that excludes the -5 and 5, okay? Because nothing else has been added in. Okay, last one for this page. Let's do f divided by g. Okay, so here we go. We're going to have this first one. This is f divided by, I'm just going to do it this way. You can make the gigantic complex fraction if you want to. Okay, everybody okay with that step? All right. What happens when you divide fractions? Do you remember the little 3-step situation? Good. So we're going to keep, change, flip, right? Or however you like to remember it. Oh. Okay. So yeah, we're going to keep. Here we're keeping. I don't know why that got weird. Just pretend that's one big parenthesis. Okay, change to multiplication. And then we're going to flip this guy over here. All right. Does anybody see anything we could cancel now? Exactly, the x squared minus 25. Now we have this really awesome situation where we can turn this into this. And we're done. Okay, so we keep, change, flip, or we turn it into that. Now, is our domain still good? There's a new situation here, right? Our original domain only excluded +5 and -5. Who else do we need to exclude? A 2. Because remember, we take the denominator, we set it equal to 0, and now we want to say x cannot equal 2. That's what we want to say. Okay, now our old domain, hold on. I got carried away being too low. All right, let's move that and move up this. Okay, so our domain looked like this. This is what our original domain looked like, right? That handled the parent functions. Now we also want to say x cannot equal 2. So now we've got to slide that 2 in there. If you can look at this and tell exactly where that would go, good for you, because these are in order from negative to positive. So a +2 is actually going to fit right in there. But if you would rather go back to our good old number line, here's -5 that we're going to exclude. Here's a 2 that we're going to exclude. And here's a +5 we're going to exclude. You can always go back and then write all these intervals. You're going to have one extra interval in there and put that in, you can. So if you can see it from here, good for you. If you can't, it's no big deal. Just use this. So our new domain, the new domain for this guy is going to be negative infinity to -5. That didn't change. But now -5 is going to go to 2 for that new little interval. Unioned with 2, right? Because that's how we exclude it, to 5. And then 5 to infinity. So this is our new official domain for the division. Just look at the difference. It's not that different. All we did was write in here, because that's where the 2 goes. We ended the -5 with a 2, unioned, then started a 2 to continue to 5. So this is the new little piece that went in there that just said it also cannot equal 2. Okay? Yes, up. The other part. Okay. There. Yes. Exactly. So usually, okay. So usually it's the quotient part. It's the division that puts something else in, because you are, you know, creating a new little denominator. So usually that's what ends up putting something else in. Yeah, it's a lot of algebra, moving parts. Yeah. Okay, last one of these. And again, I know that you guys know, you now get the domain situation. I feel pretty confident, 80% confident, but let's just make sure we can do all the other algebra stuff. Say that. Yeah. Yeah, good. Okay, so first thing we're going to do is F plus G. So we're going to add these together. Here's our F. Here's our G. Did they have the same radicand? No. So there's your answer. And I forgot the domain. Sorry, I forgot to do that. Marcella's trying to remind me, and I wasn't paying attention. Okay, so there's F plus G, but I forgot to worry about the domain. So let's stick some domain stuff on there. Okay, first of all, he's a radical. So what am I going to do with the stuff inside to find his domain? I'm going to set it greater than or equal to 0. Okay, and I'm going to find his domain. All right, so if I solve this for x, I'm going to subtract the 7 to the other side, and I get x is greater than or equal to 7. Okay, all right, let's try this little guy over here. All right, if I take his radical, his radicand, and I set it greater than or equal to 0, and then I solve for x, I'm just going to subtract my 5, I have that. Okay, now using these two, we need to form a domain. All right, well, sometimes it's helpful, of course, if we do a number line. So here's negative infinity, here's positive infinity. All right, let's see, here's -7. It's smaller than -5. Okay. All right, so if I want to graph this, and remember, a radical is the only time you'll ever have a hard bracket in a domain, right? So if I want to graph him, I'm just going to do him like right up above here. So he would be greater than or equal to -7. That would be his domain, right? Okay, what would be this guy's domain? Greater than or equal to -5. There's his domain. To get the domain for all the little baby functions, you have to take the part that these two have in common, or the most restrictive part. So this guy says it should be this whole thing, okay? This guy says it should be this thing. So what part do they have in common that they both agree on? The -5. So your domain for everybody is going to be this. Okay, so you have to take the domain of each parent function, graph it if you need to, or just think about it, and then choose the part they have in common. Okay? Say that again, Tamia. Well, so let's say, okay, let's say that we had x is greater than -5. Well, let's say this is a positive, and let's say this is -7. Okay, so if we do this, we've got a -7, here's a +5. So this one would be this whole part. This one would be just this little part. Then the only part they have in common, so your domain would be this or that. Does that make sense? I don't think I'm understanding your question, but I'm not answering it. Okay. Sometimes I just stumble into it. Okay. Yes, whatever they're both eliminating, whatever they're both shading in, that's the part you want. But they'll both go the same direction. You won't have some crazy situation where you've got like one domain way over here and one way over here, and they don't have anything in common. You know, you'll always have them that's like one is a piece of the other one, if that kind of helps. And you just choose the one that's the little piece of the other one. Okay. All right, let me get this to focus again. There we go. Okay, so we already did F plus G. We didn't recreate anything new, so we're going to keep that domain. All right, let's try a minus. So we're going to have F, right, minus this guy. Now I put him in parentheses just to be consistent, because that's what you do. You put the second one in parentheses and you distribute the minus through there. Am I allowed to go inside here and distribute a minus? No. So in this case, it's actually just this. And you're done. That's it. And again, I didn't recreate anything new. So there's my domain. All right. Now let's multiply. Now this could open a whole giant can of worms where you'd be sitting here doing algebra forever, but you don't have to. Again, they're testing you to see if you understand that you're multiplying them together, not to see if you can do that algebra. So all you're going to do is line them up like this, like they're going to multiply, and you're done. You don't actually have to do anything else with them. So don't get too carried away, okay? That's all you have to do. You can stop. So make sure when you get to your My Math Lab problems, you pull this packet out. That's what you're supposed to be doing anyway. Pull your packet out and look at the problems, because it will really help you. Otherwise, you may just go down this rabbit hole where you're doing algebra forever, okay? Now, did we recreate anybody new? No, we're still there. All right, last but not least, let's see if we have a change, and we're going to have a change. Okay, F is on top, G is on the bottom, and again, you're done. All they want to know is that you know where things go, okay? All right, but there is a change because we've never had a denominator, and now we have a denominator. And the rules for a radical are different if they're in the denominator or if they're in the top. So this, okay, I'm going to bring over here. He's no longer going to be set greater than or equal to 0. He's just greater than, because I don't want him to be 0 in the bottom. So if I subtract my 5, there I go. Okay, so let's think about this. This was my domain, right? This was the old domain. Okay, and the old domain looked like this. What does this new little piece say? Parenthesis, this way. Yeah. So what are we going to do with our domain? Yeah, we're just going to change this. We're going to say, actually, let's just do that. And that's what we changed. Okay. No, not at all. Yeah. So that's what we changed. Right. Can't be included. So, yeah. All right. Does everybody see that? That's a pretty big change there. So we're not including it anymore like we did before. We're changing it to a parenthesis. Okay. All right, so we've done domain to death. We've done combinations all over the place. The very last part of 2-6 are compositions or composites. So I know you've done this in Algebra 2. Let's just remind ourselves what in the world a composition is, and then we're going to jump right in. Okay, so this is just a little kind of baby step situation down here to bring us into compositions. So let's say we have g of x and it equals 5x squared. What's g of 3? What would you do with the 3? You're going to plug it in for x. So it's going to be 5 times 3 squared. Okay, be really careful here, because I still, every once in a while, will run into a student that thinks they're going to take 15 and square it. Exponents first. So you're going to have 3 squared and then multiply it by your 5. All right, that's actually a composition. You've been doing it a long time. We call it evaluating when it's just a number. This would be a true composition, which we've also done, and we touched on it a little bit in intermediate. So instead of putting in 3 every time you see an x, you're going to put in a whole nother function. You're going to put in x minus 3. So what that means, remember, this is our g of x is up here. We're going to have 5, and we're going to replace x with x minus 3. Then we do have to clean this up. And x minus 3 squared means there are 2 of them. Okay, so we don't want to distribute the 5 yet. We want to FOIL first. So I'm going to FOIL and put that answer inside parentheses, and then we'll distribute the 5 at the end. So we're going to do x times x, and x times negative 3, and negative 3 times x with a 9. We'll clean that up a little more, and we get x squared minus 6x plus 9. Now we're going to distribute the 5 through there, and we get 5x squared minus 30x plus 45. And that would be our answer. So what we just did is make a composite. Okay, we made a composite. We put one function into the other. So that's all we're going to do now is try putting one function into another. But just like combinations, they kind of have a funny way, a funny direction. So we want to make sure when you see the directions for a composite, you don't get confused because they're a little strange. They don't say the word composite. Okay. All right, here we go. Is it okay if I flip? All right. Okay, so here we go. Composites are the only thing in math and English that you don't read from left to right. Okay, when you read a sentence, you read it from left to right. When you read a math problem, you read it from left to right. Compositions, you read the other direction. You read from right to left. All right, so that's what that means. That's how you know who's going into who. You have to read it backwards. Okay, here is the composition notation. That's what that means. It's a little open dot right in the middle. It almost looks like an O. Some students will be like, fog, what's fog? You know, well, it's F of G of X. That's what that means, F of G of X. So I read it from left to right, but when I go to do it, I'm gonna perform the math from right to left. This means I'm gonna take G of X and I'm gonna put it into F, okay? This one, G of F of X, I'm gonna take F of X and put into G. So that's how you know who's going into who. You take the one all the way on the right and you put it into the one on the left. So it's kind of the opposite of what you would think you should be doing, okay? All right, so we can do that all day. That's pretty good. We're going to practice. We're going to practice with just compositions, and then we're also going to try putting in some numbers too, okay? All right, now let's talk about domain because the domain's a little different. For a combination, remember that's adding, subtracting, multiplying, dividing. For those, you find the domain of both parents. Whatever they have in common, that's the domain of all the babies, unless you need something else. Okay? It's different for a composite. You only care about the domain of what's listed last. So in this case, I only care about the domain of g of x. In this case, I only care about the domain of f of x. I don't care about the domain of the other one because you are so radically changing it by putting in the other domain, putting in the other function, that it doesn't matter. Okay, so it's only the one listed last, all the way to the right. The domain of the first one doesn't matter. Then you're going to do your work. Okay, you're going to clean it up. Find the domain of the new composite that you made, the baby. Find the new guy. Then you're going to take what's in common, right? Let's get, because this is a little bit confusing. I'm going to erase that. Between this guy listed last and the new guy you just made and the baby. So it's a little different. Composites are a little different. Okay, let's try it out and see how we do on this part. All right, so here's f of x, here's g of x. Let's see what they want. The first one they want, according to this, is f of g of x. Everybody see that? So they want me to take g of x, because it's what's listed last. They want me to take 5x squared and put it into f of x. So that's what I'm going to do. You're going to just take this little guy here and put it into that. Well, that's just what it says. Yeah, if you don't want to write that, you don't have to, but that's what the thing that you're doing. You're putting that into that. You're putting g into f. And then is there anything I can do with that? I have x squared, and I put it into where this x is. So we don't have to solve it. Well, if you can't, no, if you can clean it up, clean it up. But in this case, there's nothing I can do. So there it is. Does that make sense? Okay. Now let's talk about domain. All right. Let's first talk about the domain for f of x. He was x minus 3. Does he have any restrictions? No. He has no denominator. He has no radical. All right. What about the domain for g of x? No. Nope. No denominator, no radical, just that. Okay. Now, to find the domain for this, I need the domain of g of x, which was, we said, this. And I need the domain of my answer. Okay, so here's my answer. What would his domain be? Same thing, all real numbers, because he has no denominator and he has no radical. So what do they have in common? Well, all real numbers. That's the official domain for him. Okay. All right, now we're going to go the other direction. So we did this one. We found f of g of x. Now we're going to find g of f of x. Okay. Who's going into who in this situation? Am I still putting g into f? No. Now I'm going to put f of x into g. So wherever g has an x, I'm going to put the whole f of x into it. Okay. So here's where it has an x. I'm going to put this whole thing into it. Does that look familiar? We just did that. Okay. So all I'm doing in this situation is I now took x minus 3 and I put it into g of x. Now we already did that. So if we flip back to the last page, we can just write our answer. We don't actually have to go through and FOIL the whole thing. Let's see, what was it? Thank you. Okay, Perfect. All right, now let's find his domain. So I need the domain of f of x in this case, okay? Because it was the one listed last. We already came up with that. We said it was all real numbers. Now I'm going to come up with the domain of our answer that we just did. What's his domain going to be? Same thing, all real numbers, because we didn't make a denominator. We didn't make a radical. So what's the official domain for the whole problem? Again, all real numbers. Okay. All right. Last two parts, because we did this. Now we want to find f of g, but look, there's not an x down there anymore. Now there's a -2 sitting down there. Okay, there's two different ways to do this. And I guess if I'm not recording, I could just get up. Would y'all rather me stay here or do you like me up there? Does it matter? Huh? Y'all don't care? Okay, well, I'll just sit here then. All right. And then I'll get back up. Okay. All right, so now let's look at what they want. Now they want f of g of -2. That's what they want now. Okay. There's two ways you can do this. I'm going to show you both ways, and then you can decide what you want to do. All right. So there's the longer way and there's the shorter way, but the longer way doesn't involve all the compositions. So you may like it better. So let's start with that. What this means, and I'm reading it from right to left, is I'm going to take a -2 and I'm going to plug it into G. And I'm going to find that answer, whatever it may be. Then I'm going to take that answer and plug it in for F. When all is said and done, you're going to come up with a number. Okay, so here we go. I'm going to find G of -2. I'm going to plug in -2 for X on G of X. So I'm going to have 5 times -2 squared. That's going to be 5 times 4. That's going to be 20. Okay. Now I'm going to take this 20 and I'm going to plug it into F and find my answer. All right, so if I go back up, plug in 20 for X, and we got a -3. And my answer is 17. You don't need to find the domain when you're finding numbers. So I don't have to find the domain for this. Okay, so that was kind of the longer way. All right, you plugged in numbers, but some students like that better. The other way that you can do it is find f of g. Okay, well, I already know f of g. F of g was up here. I found him. He's 5x squared minus 3, right? I already found f of g. So f of g is 5x squared minus 3. Now I can take the -2 and put it in here. So I can have 5 times -2 squared minus 3. This is going to be 5 times 4 minus 3, 20 minus 3, and you get the same answer. So it's kind of up to you. I tend to like this way better. I feel like I make fewer mistakes. I'm more comfortable putting numbers into functions than I am putting functions into functions. But it's up to you how you want to do that. Do you see, though, that you can either start here? You don't put -2 into both. You put it into the one right next to it. Come up with an answer like we did. We came up with 20. And then we put 20 into F. And then came up with the final answer. Or you can find the whole composite first, which would be f of g, which we had found earlier, and then just plug the -2 in once, and you're done. So it's up to you. Does that make sense? Okay, and you don't have to find a domain because it's a number. All right, we have one more on here. Okay, now we have g of f of -2. All right, well, I have written all over the world, so let me get a new piece of paper. All right, here we go. So if I want to find g of f of -2, I have two options, right? I can plug -2 into F, come up with an answer, and then plug that answer into G. So let's see, F of -2 would be -2 minus 3, which is -5. Then I can take -5 and plug that into G. Okay, because I got a -5. If I do that, let's see, what's my G? My G is 5 times -5 squared. That's going to be 5 times 25. That's going to be 125. And that is my final answer, is 125. Okay, that's my answer. All right, or, okay, I can find G of F. All right, well, we already found G of F. He was up here, right? So here's our G of F. Okay, so we can use this and we can plug -2 into this and we should get 125. Okay, so let's see. All right, so if I take and I put in -2 into G of F, remember that's just the composition that I had found earlier. Let's see what I get. -30 times -2 is a positive 60. I'm going to get 20 plus 60 plus 45. Sure enough, I get 125. So you can do it either way. Okay, whatever you want to do. And I don't need a domain because I only found a number. Okay.
So you only find the domain if it's given you an X?
Yes. Yes. All right. Last one where we have to do everything in the whole world here. Okay. And then we just have very specific problems that we'll need to do. All right. This section and section 2.7 are kind of the never-ending sections. All right, we're not going to worry about the domain on this one because it's going to be all real numbers for all of them. There's no denominator, there's no radical. There's no denominator, there's no radical. Nothing you make is going to create a denominator or a radical. So we're going to wait and do domains on the next page when we actually have stuff to do, okay? All right, so here we go. First thing we want f of g of x. Who's going into who? Good. G, because it's written last, is going into f. So that means x squared minus 3, you're going to put parentheses around him, and you're going to put him in right here for x. He'll be squared, and then you're going to add 2. Does that make sense? Okay, so I have x squared minus 3 going in for this x. So then I'm going to square it, and I'm going to add 2. Okay. Let me look. Yeah, you got to foil him. How about that? Yeah, you are going to have to do a little bit on him. Okay, so it just turns out that that means there's 2 of them and a plus 2 on the end. Okay. What's x squared times x squared? X to the 4th. Good. Add your exponents. Then we're going to get minus 3x squared and another minus 3x squared, a plus 9, and a plus 2. Okay, we're going to clean it up and get a plus 11 in the back. All right, there we go. So you just made f of g of x. You took g of x and you sealed them up and you put them right in for x, right into f. Okay, good. All right, let's try it the other direction. So we did this one. Okay, now let's do g of f of x. I always end up, that little dot ends up looking like it goes with the f over there. Okay, in this case, who's going into who? F is going into g. So we're going to seal up x squared plus 2, and he's going to go right into g right there. Okay, he'll be squared also with a minus 3. All right, so that means, of course, we're going to have 2 of them. Look at all the little algebra practice you're getting. Okay, you little pros. All right, we get x to the 4th plus 2x squared plus 2x squared plus 4 minus 3. Okay, we clean it up. We get x to the 4th plus 4x squared plus 1. There you go. Okay. All right, last but not least, we're going to try the -2's again. I don't know why they like that so much, but they tend to like it. So if you look back up at the top, it now says f of g of -2. Okay, you have 2 options. You can find f of g, just so happens it's this guy right here. You can put a -2 in here and come up with the answer if you want to do it that way. I'm going to do it the other way just because a lot of times you haven't already found the compositions. So sometimes it's easier just to do it that longer way. Okay, so first thing I'm going to find is g of -2. All right, I put in a -2 for x. I get a 1. Okay. Now I'm going to take the 1 and I'm going to put it into f. So I'm going to get 1 squared plus 2. My answer is 3. There we go. Okay. Everybody get that all right? Okay. And then if we do it the other way, g of f of -2, again, we already know g of f. It's this guy here. He's kind of complicated. If you want to throw in a -2, you can, and you'll find the same answer that we're going to get. Or you can find f of -2. That's the part I'm going to do first. Okay. So I'm going to have a -2 squared plus 2. And I get 6. Okay. Then I take my 6 and I'm going to plug it into g. I'm going to get 6 squared minus 3. And my final answer is a 33. Okie doke. All right, I think you've done that to death. You pretty good on those? Okay, last page of this section has you just doing 2 little examples, and we're going to talk about domain because they're a little different. Okay, you don't have to do every living thing in the whole world. You're just going to do something very specific, and then you're good. Okay. All right. Okay, so on the next page, we now have a radical in play. Notice f of x is square root of x. Everybody see that? So we want to find f of g of x, and we're going to need to find the domain because we're no longer just going to have this nice little all real number situation where we don't really have to worry about it. Okay, so this is the only thing they want you to find. We don't have to find everything. Who's going into who? The G is going into the F. Perfect. So this little package here is going to be going in for X, which means he is going under a radical. You agree with that? Okay, so let's go ahead and find that, and then we're going to do the domain. So F of G of X, I'm just going to take that X minus 3 and I'm going to throw him under there. And that's all there is to do, right? That's it. Okay, now we need his domain. So do I need to find the domain of f of x and g of x? No, I only need to find the domain of g of x, right? Because he's the one listed last. So let's see if we can find the domain of g of x. Okay, what is the domain of x minus 3? It's all real numbers because there's no denominator and there's no radical. So he's actually all real numbers. Awesome. Okay. Now I want the domain of this guy, the new guy that I created, the square root of x minus 3. Okay, that means since he's a radical, I'm going to have to take his radicand greater than or equal to 0 because he's not in the denominator. So he has to be greater than or equal to 0. I'm going to add 3 to the other side. There we go. Now, I'm going to need the domain to be this and this, whatever they have in common. Okay, so if you already see it, throw it down. If you don't, let's talk about it. So here's the domain of g of x. It's everybody. Okay. The domain for this answer is going to be hard bracket this way. So what do they have in common? Yeah, this little part here, because you had everything and then one that sort of just took part of it. So the thing they have in common is this part of it. So when I write him in interval notation, that's the official domain. Okay. Does that make sense? Okay with that? All right. Last one on here. Okay. Is it okay if I scoot him up? Okay. I'll talk for a minute and then we'll scoot him up. All right. So we have a radical here, just like we did before. All right. Now we want to find f of g of x. Same thing we found before. Who's going into who? G is going into f. Okay, perfect. So let's throw him in there. All right. So he is a radical. We're still going to seal him off and we're going to put him in here. All right. We're going to do a little bit of work too on clean him up. I'm going to see how much you remember from intermediate. Okay. So f of g of x. Okay. So I'm going to put in this radical. He gets squared plus 8. You can. So this right here, you have a square root being squared. What's going to happen with all that stuff? It's going to kind of just come out in the wash, right? When you square a square root, the radical comes off, the square comes off. All you're left with is the stuff inside. Plus 8. Awesome. Okay. This could either come out to be 15 minus x or negative x plus 15. Honestly, it doesn't matter. I mean, of course, this is a little bit more correct, but it really does not matter. You choose. Okay. All right, let's find our domain now. Again, I don't have to find the domain of both of these guys like I did with a combination. I only need the domain of the one in the back. So I need to find the domain of g of x. Okay. So domain, hold on. You're ruining the suspense of the domain. Okay, so it's going to be 7 minus x greater than or equal to 0, right? Okay. We subtract our 7. Uh-oh, we're still not solved. What are we doing now? Divide by -1. What happens? We flip our inequality, right? Okay. What would be the domain of this guy that we just made? All real numbers, right? Because there's no denominator and there's no more radical. So when we go to figure out what they have in common, this one is everything. This one is a 7. Did I flip him right? Yeah. I'm putting the wrong bracket in. That's what I'm doing. Okay. Wrong bracket. There we go. He goes this way. So what do they have in common? Yeah, that little dude over there. So you're going to have negative infinity to 7 with a hard bracket, and that will be the official domain. Okay, so 2.6 was a beast. You know I could get through another page, but I'm going to let you off easy. I'm sorry about the recording messing up. Looks like the Wi-Fi is back on. I'll send whatever little part did record, and we'll hit 2.7 Friday. So don't forget, tomorrow, yay, college algebra.
Yeah, didn't we just have a Friday?
No, sorry.